Okay, now last part of lesson 1 is we're going to talk about power of a product. Now when we talk about a product, we're talking about basically, like a mixed monomial, right? So we're talking about something that has, that can have numbers in more than one variable, and it can be pretty icky stuff. And like occasionally you're going to see something that looks like 3x cubed y squared z to the 4th power, right? And you get something like this, and it's like, how on earth do you evaluate this, and how does this work? Okay, so we're gonna kind of show you that. So the general rule of this, right, is whenever you do this, think of this almost as using distributive property with the exponent. All right, so think of this as almost like distributive property with the exponent. So any individual term that makes up that monomial is going to get this m applied to it, all right, including numbers, right? And if it already has an exponent, you're going to apply it to that exponent and do what we know what we do. When you take a power of a power, we just talked about that, you multiply them, right? And now the reason this works is because you're basically taking whatever is inside that and you're just multiplying it by itself 3 times. And so if I took this thing right here, right, and they kind of break this down and show you this, but like if I did this one here, right, it would basically be the same as saying, okay, I got 3x to the 3rd y squared z times 3x to the 3rd y squared z times 3x to the 3rd y squared z times 3x to the 3rd y squared z. I'm running out of room, but you guys get the idea, right? And then it's just a matter of, okay, let's get everything by each other, right? So let's deal with my 3's first, right? So I got a 3, I've got a 3, I've got a 3, I've got a 3, and we're going to multiply those, right? So you're going to go 3 times 3 times 3 times 3, which is going to give you 81, because you get 9 and 9, and 9 times 9 is 81. All right, so that gives you 81. Next, and I'm going to switch colors here, all right? Next, we're going to do our x to the 3rd. So we've got 3 of them here, we've got 3 here, we've got 3 here, and we've got 3 here, right? So that means I have x to the 12th power, because you add them. You go 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12. All right, let's switch to green. Let's do our y's, okay? So I've got y squared, I've got y squared, I've got y squared, and I've got y squared. So you've got 2, 4, 6, 8 y's. So I've got y to the 8th power. And then the last thing, and we'll use blue because it's the next one, is you've got 1z, 2z's, 3z's, 4z's. So you have z to the 4th power, right? Because it's z times z times z times z. So the fast way to do this, all right, the quick way to do this, if you're like me and you're just like, that took way too long, because it did, is you're going to raise 3 to the 4th power. So you're going to say, I have 3 to the 4th power. Now you're going to say, okay, I'm now going to take 4 and apply it to my x term, all right? And so that means that I have x to the 3rd to the 4th power. So I have this, I have x to the 3rd to the 4th power, which is x to the 12th, okay? Because we talked about that whole power of a power thing. If you're just watching this video and you don't understand the other properties, please go back and watch those, otherwise, and it makes this a lot easier, all right? We're going to do the same thing with y squared. So that's the same thing as saying we're raising y squared to the 4th power. So we should know that we're going to raise this by multiplying those. So that's going to give me y to the 8th power. Another way of thinking of it is 4 groups of y squared. And then with my blue color here, we are going to take the 4 and apply it to the z. So you're going to get z to the 4th, which we don't really have to do any razzle-dazzle with. And that's how you get your answer. And so the quick way is just multiply these by your exponent. And then we're not quite done, all right? So then the way you take this is you realize that I can't leave 3 to the 4th as 3 to the 4th. You can leave everything else like that, but numbers have to be simplified, all right? So numbers must be simplified. All right, so you'd have to figure out 3 to the 4th. You'd have to just do that. You can do it in your head, or you can do it on the calculator. You can put 3 to the 4th in on the calculator. You get 81, and then you just write the rest of it out. So you got x to the 12th, y to the 8th, and z to the 4th. Okay, so that's kind of the long, protracted way of how to do this. Now let's kind of zip through a few of these. All right, so we've got jk to the 5th power, which means we're taking this exponent and we're applying it to both of those terms. So this is going to be j to the 5th power and then k to the 5th power. Ask yourself, is there any more simplifying I can do? And no, there really isn't. Okay, those look good. Now, I'm going to take this 5 and I'm going to apply it to my x's and I'm going to apply it to my y's. And notice I'm pointing it at the exponents that they already have. So this is going to give me x to the 2 times 5 power. And then this is going to give me y to the 4 times 5 power. And so, yes, I can simplify those. So that's going to give me x to the 10th over y to the 20th, right? Which is also the same thing as saying I have x squared y to the 4th 5 times, right? And if you did that and you added, you would get to this. All right, and this last one, all right, is basically saying the same thing as, and then now watch, because I'm using a negative, I'm going to keep that in parentheses. I'm raising negative 3 to the 3rd power. I'm raising a to the 3rd power because I'm applying this to everything. And then I have b to the 4 times 3 power. Okay, well, negative 3 to the 3rd power is negative 3 times negative 3 times negative 3. So you get positive 9 times negative 3, which is negative 27, right? So we're going to go negative 27, right? And then you get a to the 3rd. That's as simplified as it can be. And then we have b. 4 times 3 is 12. B to the 12th power, and you are finished. All right? Once you get the hang of these go fairly quickly. I'm not going to say they're easy because they're kind of weird to understand, but once you just kind of remember the difference between multiplying things and taking powers of things, it becomes a lot simpler, right, and more straightforward. So good luck with these guys. There will be videos coming later on the homework, so you can look at those. All right, but those will be released strategically at a later time so that you can start checking your homework over. Okay, so great. Thanks for following along, and good luck with these.